Good. Okay. So this will just, again, for people just joining, this is just going over forking. This isn't actually going over any of the test review or anything. Again, that'll be on Wednesday. I'm doing forking so that this is just fresh on your mind. So tomorrow you can just go in and know what to expect. I'll be there tomorrow. Well, in the morning class. I don't know about in the first class. I don't know about the second one. So if you still have any more questions, you can probably come talk to me. It's not too bad. If you've been paying attention to processes and sub-processes and stuff, this shouldn't be too hard. So I have an example here. This is an example output. Your extra credit is going to look very similar to this, I will say. Not exactly this, but it'll look similar. So yeah, basically, let's go ahead. Let's start with just going over and analyzing what this is. Basically, we are going to need to use multi-threading to output these processes in this order, and they must be child and grandchild processes from the corresponding parent process. So starting off, what we can do is this is going to be our initial parent thread, right? Because this is the main. So this is the starting thread. So we can go ahead and just see out I am the parent process, and then we should be good there. Any questions so far about why we put the parent process right in the main before doing anything? Okay, good. Now we need to start printing out the child process. Now there's a bunch of ways to do this, some more efficient than others. I'm going to do what I did when I was in the class, and so whether this is embarrassingly inefficient or not, I don't know. That's up for you to decide. But what I'm going to do is I like to read the amount. I like to read the amount of processes that we totally need to print. So in this case, we have 3 different processes, right? 3 unique processes, but different grandchildren. You don't really need to worry about the grandchildren when you make a loop at all, because inside our loop is where we're going to worry about printing the grandchild process. For now, our main loop is going to correspond to just the child processes, okay? So what we can do is we can just go ahead and create a for loop, and we have 3 unique processes. So, for int I is equal to, I is equal to 0, and then we'll do 1, and then we'll do, well, I is less than 4, because we need to do this 3 times for the unique processes, and then just like that. So the idea here is that this is going to be printing out our child and grandchild processes. Any questions so far? Okay. Now, in here, we can immediately, from our loop, start actually forking our process. So what I talked about earlier before some of y'all joined was that I think Rincon likes to do this, where he puts PID and then he says fork, and then he does that. I think he likes to do that. Oh, I need to import this. I'm sorry. And the reason he likes to hold PID is because remember that fork is being called as soon as it's...
Làm gì vậy? Dễ thương vậy. Em chụp lại.
I'm going to mute
Anh
you.
boss, I'm sorry.
Okay, sorry. Fork is being called as soon as it's being written down. So it's just like a function, obviously, where as soon as I write it here, fork is being called, and it's creating a subprocess. And then what it's returning is an integer, and this integer is the value of whether or not the fork was successful. So I'm going to, real quick, I need to include this, and then I need to include waiting because system wait .h. Hopefully this works. This is not working. You know what? Whatever. Okay. Hopefully this will just... I swear I tested this before. I'm sorry. I don't know why this is like not working. Oh well. Okay. Anyway, so we're going to create a fork, and we're going to start forking our process. And we're going to store the PID in here. And at this point, the child process has been made. So child process has been made. Okay. So now anything further here is a sub-process of this process. So anything when we start going further, it's a little confusing, but essentially we are now entering a child process. And we also have to make sure if the child process was successful. So that's why we do the if PID is equal to 0. Because if it is successful, then PID is 0. And now from here, we can see out I am the child process. Now, a thing that I think trips people up is how do we know when the child process is corresponding to the parent process? Well, that is according to our I, because our I is keeping track of how many forks we're creating and how many processes we are making. So in this case, if we say that after we've created the fork, and this is our first iteration, this has to be the first child process. So we can just say I here, and that'll work. Yeah, and then of course you have to remember wherever you are forking, whenever you fork, you need to wait. And if you need to wait and then null pointer, because if you don't, this is what causes you to get out of sync with your processes. So, it could print out 2 first and then the grandchild and then 3, it's random. So make sure, and this is in general also on your exam, when you're asked to fork or create a process, wherever you do it, in that same, indentation, also put in the wait, okay? Very, very important here. Okay. Again, I don't know why this isn't, I think it's because my IDE is a little weird, but you're just gonna have to trust me that this is right. I promise this is right. Okay. So now what we can do is we have a child process for I. Oops, sorry. But what about the grandchild process for I? And this is where the efficiency of the coding comes in. What I like to do is I like to just say, inside here, when the fork is successful, okay, when we're inside the child process, we just check if, we just go ahead and check, so I like to check if I is equal to 0, then we can go ahead and make a child process, right? And how do we make a grandchild process? Well, the same way we made a child process, where we just do PID is equal to fork. And now this creates a grandchild process. Okay, so into our loop from the parent process, fork, now we're in a child process. If that's successful, see out that we are the child process. If we're at I is equal 0, which means that I is equal to 1, I apologize. If I is equal to 1, meaning this is our first child, then we can create a grandchild process because we need to follow this here. But we also need to make 2 grandchild processes. So what we can do here is you simply just check where if I is equal to 1, then we can loop again. So for integer x equal to 0, while x is less than 2, x plus plus. And now inside this loop, because we have to make 2 grandchild processes, we can go ahead and fork inside this loop. So we just take this, and we put it in here, and now we are forking enough times. So and then down here, of course, we just check if PID is equal to 0, because again, this is how we make sure that this was successful. So I'm gonna write down check to make sure the bro. Oh, okay, thank you whoever did that. Check to make sure that the forking was successful. Also, I'm really bad at spelling, so if that's spelled wrong, sorry. so again, we have to always do that every time. Make sure you always check if PID is equal to 0, because if not, you might be forking, and then you're going to get a weird output if it's not successful, and it's just going to be all weird. So now we can see out, I am the grandchild process of, from child process, and then I, right? So, okay, sorry about that. So there we go. And the reason we do I here is because, again, this is we check if I is equal to 1. So we check if I is equal to 1, check if this is the first child process. Okay. So that's why we do I here, obviously, because I corresponds to the child process that we're in. And you could rename I like child process number or whatever, but that's just up to you. And again, make sure every time you call fork within the same indentation, you call wait null pointer. That's always important. And yeah, so now we're pretty much done. At this point, we have created I am the parent process. We go in here, we say, okay, well, we're going to need to make 3 more child processes. So prep our loop. Let's go ahead and start forking. So we've created a child process. Was that successful? Great. See out that we are the child process for one instance of the loop. So 1. Is it 1? Okay, great. Now, because it's 1, we need to make 2 grandchildren processes. So now we need to make a brand new loop. And I think one thing I see people do is they try to fork twice. So I think that's what might trip people up, is where, well, why do I have to make a loop if I'm only doing it twice? That seems like a lot. Well, long story short, or technical wise short, it's that whenever you loop and you fork, the fork is being subcontained in this loop that's subcontained in the child process. So if you were to fork twice adjacent to each other, that's not creating a grandchild process. That's creating a great grandchild process, right? So yeah, that's why that is what that is. But anyway, now we see that child process 2 also has a grandchild process. So it's essentially the same thing. All we're doing is we just go down here, we check, well, if I is equal to 2, then we can go ahead and, because there's only 1, we don't need to make a loop, right? So we just do PID is equal to fork, just like that. And then we can go ahead and print out I am the grandchild process for subprocess I. Again, we could use I because we're still inside this our main for loop here. And that will work just fine. Again, make sure you do waiting your null pointer here. And perfect. Oh, I'm sorry. I forgot like the biggest thing ever. We gotta check if PID is equal to 0. Of course. I apologize. Just tell you how important that is, and then don't do it at all. Okay. So, yep. And then of course now here we have I am the child process 3. So again, if you want, you can do it this way, where we just say we could just check if I is equal to 3. Well, actually, we don't need to do that, sorry, because we already have our child process right here. It's already doing it 3 times, so this is our default here, and we should be good to go. Again, the final thing that will trip everybody up is right here. We need to make sure, I think this is lined up with the for loop. So inside this PID is equal to 0, we forget one thing. We have to exit the thread. Inside every if statement, we have to make sure that we exit the thread, and this is important because otherwise our thread will continuously be processed, and essentially it will never leave itself, and so we can't process the parents. So make sure that every time you have a if PID is equal to 0, at the very end, you have a underscore exit 0. And this is a protocol given in C++ that when called will exit its process. So in here, of course, we need exit 0. And then we do that for PID here. So I guess a way to look at this simply is every time you have a if PID is equal to 0, you need to have an exit that corresponds to it. And if you have a PID, you need to have a if PID is equal to 0. Okay. Also, every time you create a fork, you need to wait on the same indentation under the same context. So yeah, this is the code here. Let me try to condense it if you want to take a screenshot or whatever. And try to fit it on one page. There you go. So this will give you this output. Just a kind of a trust me bro moment, because I can't I can't run it for some ungodly reason, but yeah, this should give you everything. Any questions or anything? And I'll put up the output here too, so you can just pretend that this is our output. Okay.
Quick question: is the reason that you can't run it is because you missing the include sys/wait?
Yeah, my IDE, I use CLine. I don't use
Oh, okay.
I don't use, this isn't Visual Studio. This is a different IDE that is way too expensive for it not to work. But yeah, let me try to import. I don't think wait.h is like a thing on here. Yeah, I don't even have that. Like, I have to go in here into my CMake and all that. But anyway, yeah, any other questions? If you understand this, if you can follow along here, or even if you can just memorize like this or understand these rules of forking, waiting, and exiting, there's no doubt in my mind you'll get 100. It's all or nothing tomorrow, so even if you get a few threads right, it's not, you're not going to get any points unless you get it all right. So
sorry.
No, you're good.
So for tomorrow, we do include the sys.
No, you don't have to worry about that. Don't worry about any of this. This will all be,
Oh, okay.
yeah, don't worry about any of that. That'll be for you in Moodle. You're going to be coding in Moodle. You cannot use your own IDE for the extra credit. Like, you can't, I don't think you, yeah, well, maybe he'll let you. He didn't let us, but I think he wants you to just code it straight in Moodle. He's also going to give you an example code. Like, when you open Moodle, it's not going to be an empty thing. He's going to give you like how to at least create one fork, like how to properly write one fork. So even if you don't remember the PID is equal to fork and 0 and exit and wait, this like little indent right here, sorry, this one here is actually going to be provided for you. So not even that much to remember or understand, I guess. Any other questions? Okay. Well, I'm gonna stop the recording.